China built a Ferris wheel between two skyscrapers. Not at the base, not in a courtyard. 425 feet in the air, suspended between two occupied hotel towers, rotating guests through the sky, while thousands sleep in rooms just meters away. The Golden Reel at Studio City Macau, the world's first and only figure-8 Ferris wheel integrated into living buildings. What you're about to discover is how engineers turned an impossible vision into 3,200 tons of spinning steel that defies every rule of structural design. But before they could spin a single rotation, they had to solve a problem that threatened to kill the entire project: the Studio City gamble. The year is 2013, and Melco Crown Entertainment is staring at a $3.2 billion problem. They're building Studio City Macau, a massive Hollywood-themed resort in the world's gambling capital, and they need something nobody's ever seen before. Macau isn't just competitive, it's brutal. The Venetian has gondolas. City of Dreams has a water show that cost $250 million. Wynn has fountains that dance to music. Studio City needs a centerpiece that makes all of that look ordinary. The architect presents the concept: a golden Ferris wheel connecting two hotel towers. Not beside them, between them. The design mimics a figure-8 two loops, intertwining like a ribbon frozen in metal. It's meant to symbolize the golden age of Hollywood, a nod to classic film reels. Beautiful on paper, terrifying in reality. The towers are already designed, 38 floors each, hotels that will house thousands of guests. The wheel has to connect them at the 19th floor, 425 feet above ground. And here's the part that makes structural engineers go pale. It has to rotate, constantly, smoothly, silently, while guests sleep in rooms just feet away from tons of moving steel. The initial engineering assessment comes back with a single word in bold: unprecedented. There's no building code for this. No reference project. No proven method. Traditional Ferris wheels sit on the ground where gravity works with you, where you can pour massive concrete foundations that anchor everything in place. This wheel would hang in the air, its weight borne entirely by two towers that were never designed to hold a rotating structure. But Melco Crown doesn't have a backup plan. Studio City's entire brand identity is built around this golden wheel. Investors have been promised it. Marketing materials feature it. The opening date is locked in for October 2015. They have 2 years to build something that's never been attempted. The engineering firm hired to make this happen looks at the specifications and realizes something that sends a chill through the entire project team: the shape that changes everything. A circular Ferris wheel is predictable. Forces distribute evenly. Weight balances naturally. Physics behaves. But the golden reel isn't circular. It's a figure-8, two different curves intersecting at the center, creating a path that violates every assumption about how rotating structures work. Here's why that matters. When you create a figure-8, you're building two loops with different radii. As the wheel rotates, capsules travel through constantly changing force vectors. At the top of the upper loop, they're pulling outward in one direction. Seconds later, at the crossing point, forces shift 90 degrees. Then they're in the lower loop, pulling in a completely different direction. It's not rotation, it's controlled chaos. The engineers run the first computer simulations. The stress patterns light up their screens like a Christmas tree of structural failure. Where the two loops intersect, forces concentrate so intensely that standard steel would fatigue and crack within months. The connection points to the towers show load variations that swing wildly with every rotation. Then there's the weight distribution problem. The wheel has 17 capsules. An odd number means perfect balance is mathematically impossible. As the wheel turns, weight shifts continuously. The golden reel needs bearings that can handle forces that change direction, magnitude, and distribution with every degree of rotation. The specifications call for custom-engineered systems that don't exist in any catalog. The team runs over 6,000 simulations. Each one reveals another failure mode they hadn't considered. The steel grades specified initially aren't strong enough. They upgrade. The upgraded steel is strong enough, but too heavy, adding tons that the towers can't support. They redesign with exotic alloys. 3 months into the engineering phase, the project lead makes a call to Melco Crown executives. The message is blunt: the figure-8 design might be impossible to build safely. They could simplify to a circular wheel. Still impressive, still unique at that height, but not the iconic shape that defines Studio City. The executive's response: make the figure-8 work. The resort identity depends on it, but making it work meant solving a problem even more dangerous than the shape itself: the towers that were never ready. Studio City's twin towers weren't built to hold a Ferris wheel. They were designed as hotel towers, standard structural cores, standard floor plates, standard load calculations for rooms full of guests and furniture. Now, engineers have to retrofit them to support 3,200 tons of rotating steel without compromising the building's integrity or safety. Here's the nightmare: 8 connection points, 4 on each tower, each one channeling immense forces into buildings already under construction. The forces aren't static, they're dynamic. Every rotation of the golden reel sends waves of stress through the connection points. When capsules load at the top, the upper connections experience crushing compression. As the wheel turns and weight shifts, those forces reverse, transition to tension, then swing back to compression. The towers have to absorb this cycling load thousands of times per day, every day, for decades. The engineering team cuts open the architectural plans and discovers something terrifying. The original tower design has no capacity for these loads. The floor slabs around the 19th level where the wheel connects would crack under the stress. The columns supporting those floors would buckle. The entire structural system would fail catastrophically. The solution requires surgical reinforcement. Massive steel bracing runs through 15 floors of each tower from the 14th floor to the 28th. Each brace is custom fabricated from high-strength steel, designed to capture the rotating loads from the golden reel and distribute them through the tower's core. The bracing alone weighs hundreds of tons per tower. But here's the problem that keeps the engineers awake at night: vibration. The golden reel will rotate continuously during operating hours. Even with sophisticated bearing systems, that rotation generates vibration. If those vibrations transfer into the towers, guests in nearby rooms will feel their beds shake. Glasses on nightstands will rattle. The hotel becomes unlivable. The solution is vibration isolation, elastomeric bearings installed at every connection point. These bearings are stiff enough to transfer massive structural loads from the wheel to the towers, yet compliant enough to absorb vibrations before they propagate into the building. Each bearing is custom designed, tested under millions of loading cycles to ensure it won't degrade or fail. Then comes the fire safety nightmare. The golden reel connects to occupied buildings. If fire breaks out in a capsule, it's 19 floors up with no ground level access. The engineering team has to integrate fire suppression systems into the wheel structure, create emergency communication links between capsules and tower control rooms, and design evacuation protocols for guests who might need to escape from a capsule suspended 425 feet in the air. The building authorities in Macau review the plans and throw up red flags everywhere. There's no code for this, no precedent, no testing standard. The engineers have to write their own criteria, then prove through analysis and testing that their design meets safety standards that don't technically exist yet. 4 months into the structural design phase, a stress analysis reveals something that nearly kills the project. The 8th connection point, the lower right attachment on the 2nd tower, shows a stress concentration 20% higher than predicted. That 20% is the difference between steel that lasts 50 years and steel that cracks in 5. The entire connection system has to be redesigned. Then comes the question no one wants to answer. Can the towers even be built with all this reinforcement while staying on schedule? Building what doesn't exist. By late 2013, fabrication begins on components that have never been manufactured before. The golden reel's main structure requires steel sections with tolerances measured in millimeters. Not close enough. Exact. Because when you're assembling a 130-meter structure, 425 feet in the air, there's no grinding things down to fit. The frame itself is a masterpiece of structural geometry. Massive curved beams form the 2 loops of the figure 8, connected by a central hub where the paths cross. Each beam is a complex three-dimensional curve, twisted geometries that transition from one radius to another while maintaining structural continuity. Fabricators use CNC machinery to cut and shape each piece in climate-controlled facilities, where temperature is monitored constantly. Steel expands and contracts with temperature changes. A beam that fits perfectly at 20 degrees Celsius might be millimeters off at 30 degrees. Those millimeters matter. The bearing system is unlike anything used in conventional Ferris wheels. Traditional wheels use a single central axle. The golden reel uses a distributed bearing system, multiple bearing assemblies positioned around the structure, each one carrying a portion of the rotational load. These aren't off-the-shelf components. They're custom-engineered assemblies, each bearing tested to 2 million rotation cycles before approval. The drive system needs motors powerful enough to rotate 3,200 tons, yet precise enough to control speed within fractions of a rotation per minute. The motors are positioned at the central hub, driving the wheel through a gear reduction system. Backup motors and emergency braking systems add redundancy if the primary drive fails. The wheel doesn't just coast to a stop, it's actively controlled every second. The capsules themselves are engineering marvels disguised as steampunk-themed gondolas. Each one holds 8 passengers in climate-controlled comfort. These capsules travel through a figure-8 path, experiencing forces that change continuously. The floor has to stay perfectly level throughout the entire rotation. That requires a gimbal system in each capsule, allowing the passenger compartment to self-level even as the wheel carries it through curves and transitions. The golden exterior, 11,000 LED lights embedded in the structure, creates a technical challenge. Each LED needs power and control signals. That's 11,000 individual connections that have to survive rotation, vibration, weather, and years of operation. When an LED fails, technicians need to replace it without shutting down the entire wheel. By mid-2014, fabricated components start arriving in Macau. Massive steel sections, bearing assemblies the size of cars, capsules wrapped in protective crating. The construction site becomes a staging ground for an aerial assembly operation that most engineers said couldn't be done. And that's when the construction team discovers their biggest problem isn't engineering, it's logistics. Assembly in the sky. Studio City's towers are rising floor by floor, and the golden reel's components are staged on the ground, waiting. But here's the problem that stops everyone cold. How do you assemble a 130-meter Ferris wheel between 2 buildings that are still under construction without dropping 3,200 tons of steel on one of the world's busiest casino districts? The cranes required for this job don't exist in Macau. Massive tower cranes have to be brought in, assembled on site, anchored to custom foundations, then climbed higher as the towers rise. 2 cranes, 1 for each tower. Their coordination has to be perfect. The assembly sequence becomes a 3-dimensional puzzle. You can't just start anywhere. Every piece of the golden reel depends on other pieces for support. The central hub has to go up first, the point where the 2 loops intersect. But the hub can't float in mid-air. It needs temporary support structures, steel frameworks that hold it in position while connections to the towers are made. The first major lift happens in March 2014. The central hub, 60 tons of structural steel, rises slowly between the towers. Wind is the enemy. At 425 feet, even moderate winds create forces that swing suspended loads like pendulums. 2 cranes working in coordination, their operators communicating constantly, inching the hub upward meter by meter. It takes 4 hours to position it, another 2 to secure it to temporary supports. Then the curved beams start going up. Each beam weighs between 15 and 30 tons. Each one has to be lifted into position, aligned with millimeter precision, then bolted and welded to the growing structure. Welders work in harnesses, suspended beside the structure. Their work inspected by quality control teams, who reject anything less than perfect. A bad weld at this height, under these loads, means catastrophic failure. But here's what makes this assembly truly insane. Studio City is partially operational during construction. The tower's lower floors are opening to guests. The casino is running. Restaurants are serving meals. And directly above them, construction crews are dangling massive steel components, working against deadlines that slip every time weather turns bad. The bearing assemblies go in next precision instruments weighing several tons, with tolerances measured in hundredths of a millimeter. When testing begins, the bearings turn smoothly until they don't. A vibration appears at certain speeds. Engineers trace it to a single bearing that's 0.03 millimeters out of alignment. That's the width of a human hair, and it's enough to ruin everything. The bearing has to be removed and reinstalled. By August 2014, the figure-8 structure is complete, a golden skeleton hanging between two towers. The construction team moves to capsule installation. Each capsule weighs 3 tons and contains hundreds of components. Installing 17 capsules means 17 crane lifts, 17 alignments, 17 attachment procedures. The final phase is system integration, connecting the drive motors, installing control systems, running electrical lines for the 11,000 LEDs, testing emergency systems. This isn't construction anymore. It's surgery on a mechanical organism spread across 130 meters of airspace. Then, in October 2014, 1 year before the scheduled opening, comes the moment that defines everything: the first rotation test. The test that couldn't fail. The golden reel sits silent between the towers, complete but untested. Every structural calculation says it should work. Every simulation shows success. But simulations don't account for reality. Materials that behave slightly differently than predicted, connections that aren't perfectly rigid, forces that interact in ways computers can't fully model. The first rotation test will answer the only question that matters: does it actually work? The test happens at 4 in the morning when winds are calm. No passengers. Just the structure itself, ready to move for the first time. Engineers position themselves at every critical point: stress gauges on the tower, connections, vibration sensors on the structure, cameras capturing every millimeter of movement. The control room is packed with people who've spent 2 years making this moment possible, and they're all terrified. The drive motors engage. A hum builds through the structure. Then, slowly, the golden reel begins to turn. The first rotation takes 15 minutes. Engineers watch their instruments like doctors monitoring a patient in surgery. The tower connections are reading loads within 3% of predictions. Vibration levels are acceptable. The bearing system is smooth. The structure maintains its shape. The first rotation completes successfully, but 1 rotation proves nothing. The test continues. 10 rotations, 50, 100. At rotation 73, a sensor detects an anomaly, a spike in stress at one of the lower connection points. Engineers stop the test immediately. Analysis reveals the cause: thermal expansion. As the sun rises and temperatures increase, the steel structure expands minutely, changing how loads distribute. The control systems are reprogrammed to account for thermal variations. Testing resumes. 500 rotations, 1,000. The golden reel spins continuously for 48 hours, simulating months of operation in compressed time. At rotation 941, a bearing vibration increases slightly, solved with a different viscosity oil. At rotation 1200, an LED circuit fails. The redundant circuit takes over seamlessly. By December 2014, the golden reel has completed over 3,000 test rotations. But proving it works and proving it's safe for passengers are different achievements. That requires loaded rotations with ballast simulating passenger weight, emergency system tests, evacuation drills from capsules at height. January 2015 brings the final test: full passenger load simulation. 17 capsules, each loaded with ballast equivalent to 8 adult passengers. The wheel rotates through a full operating day profile for a week straight. Minor issues emerge: a capsule door mechanism that sticks occasionally, a sensor that drifts out of calibration. All fixed. By February 2015, Macau's building authorities begin certification inspections. They review 2 years of engineering documentation. They witness operation tests. They examine every connection, every safety system, every redundancy. In May 2015, the certification is granted. The golden reel is approved for passenger operation. October 2015. Opening day looms. The golden reel has been tested more thoroughly than most structures ever built. But there's one test remaining: the one that determines if 2 years of impossible engineering actually matters. The Reel Turns Gold, October 27, 2015. Studio City Macau opens to the public, and the Golden Reel spins its first paying passengers 425 feet above the casino district. The first riders step into golden capsules. The doors seal, and the wheel begins its rotation. 17 capsules carrying 136 people through a figure-8 path that shouldn't exist. The structure performs flawlessly. The vibration isolation works. Guests in nearby hotel rooms report no disturbance. The bearing systems are silent. The capsule gimbal mechanisms keep floors perfectly level through the entire rotation. The figure-8 path that terrified engineers becomes the experience that makes passengers gasp, a trajectory that feels like floating through three-dimensional space. In the first month of operation, the Golden Reel carries over 60,000 riders. No incidents, no injuries, no mechanical failures requiring shutdown. Daily inspections reveal normal wear patterns, nothing unexpected, nothing concerning. The numbers tell the story. 3,200 tons of steel rotating smoothly between 2 occupied hotel towers. 17 capsules traveling a figure-8 path with constantly changing force vectors. 8 connection points channeling dynamic loads through towers that weren't originally designed to hold them. 11,000 LEDs illuminating the Macau night. 0 failures in the first year of operation. Studio City's gamble pays off spectacularly. The Golden Reel becomes the resort's defining feature, the image that dominates marketing, the experience that guests travel to Macau specifically to ride. Melco crowns $3.2 billion investment centers around a structure that engineers initially said might be impossible to build safely. 5 years after opening, the Golden Reel has carried over 1 million passengers. The structure shows no signs of the catastrophic failures that engineers feared during design. Maintenance teams perform routine inspections and find exactly what they hope to find. Components wearing gradually and predictably. Systems operating within design parameters. The exotic steel alloys are performing as predicted. The vibration isolation bearings are absorbing loads without degradation. The tower reinforcements are channeling forces exactly as calculated. The engineering community takes notice. Papers are published analyzing the Golden Reel's design. Universities add it to case studies on complex structural systems. Other projects attempt similar integrations of rotating structures into buildings, citing Studio City's achievement as proof that it's possible. But perhaps the most telling measure of success is this. Tourists ride the Golden Reel and think about the view, the experience, the photos they're taking. They don't think about the 3,000 test rotations, the 6,000 computer simulations, the stress concentrations that nearly killed the project. They don't think about any of it because all of it works invisibly, the way great engineering should. China built a Ferris wheel between 2 hotel skyscrapers 425 feet in the air. A figure-8 shape that creates constantly changing force vectors. 3,200 tons of rotating steel connected to occupied buildings. Every expert said it was too dangerous, too complex, too unprecedented. Studio City Macau and their engineers prove that impossible just means no one solved it yet. The Golden Reel isn't just spinning metal and glass, it's spinning proof that the most ambitious visions become reality when engineering refuses to accept impossible as an answer.